Buenos dias a todos, y'all. Today I'm going to go over 6.1 angles of polygons. Some vocabulary up top. If you don't know what a polygon is, it's basically a closed figure, so you need at least 3 sides to make a polygon, because if you only had 2 sides, they couldn't really connect, could they? Not to close it completely. They could just make like an angle. The vertex of your polygon is going to be like the corners. Then we have convex and concave polygons. Think of a concave figure as something with an angle that'll open inwards, go inside, and think of a concave as the angles that all the angles point outward. I believe you need only one angle that's concave to make a figure concave. Then we have defining defining a polygon based on the number of sides. So here I have this table down here. You see you have triangle, quadrilaterals for 4 sides. It's not just going to say square, rectangle, because there's many different types of 4-sided figures, so it's just quadrilateral. It goes all the way up to a dodecadon for a 12-sided figure. And then I believe beyond that, at least to my knowledge, they don't have any names for like a 13-sided figure. So that's why it says n-gon, n for any number of sides. So if you see something that's like, I don't know, has like 40 sides, it'll be called a 40-gon, as in a 40-sided polygon. And obviously, the more sides you have, the closer you get to a circle. So let's see here. More vocabulary. Equilateral polygon, equiangular polygon, equilateral. Obviously, all the sides are the same. All the angles are the same, or equiangular. If it's a regular polygon, that means all the sides and all the angles are congruent. Okay? So if it's irregular, then you know that not all the sides or not all the angles are congruent inside the figure. And then you have a diagonal. So a diagonal polygon is a segment that connects any 2 non-consecutive vertices. So here you can see they're already outlined in red. PR is a diagonal and PS is a diagonal. It's inside of the figure. PQ, QR, SR, ST, PT, those are all sides. So they're all connecting the polygon. So and that's why it says non-consecutive vertices anyway. Okay, the polygon interior angle sum. Basically, that says the number of sides of a polygon. Plug this into this formula, and you will know the interior angles of that polygon. You will know what each one should be, assuming it's all a regular. These are all regular polygons. So you can see with this example here, we have a 5-sided figure, and so we plugged it in 5 for n. So 5 minus 2 is 3. 3 times 180 is 540. So let's do some examples here. Okay, so basically just have this table set up so that you can plug in any number of these sides, at least up to a dodecadon, and we can figure out the sum of the interior angles. It's funny, the number keeps getting higher and higher, but the more sides you get closer and closer to a circle, and then if you get to a circle, it just goes to 360. I just find that a little interesting. So when you have 3 sides, that's a triangle. So we've gone over that. 3 sides, sum of the interior angles of a triangle is 180. We know that the sum of the angles inside a square, if they're all right angles, that's 4 times 90. That's 360. Let's fix that 8. Well, all right. From the other example, 5 minus 2 is 3. 3 times 180 is 540. And if you want, you can plug in x minus 2 in parentheses times 180 into the graph and hit Control-T on the calculator. And then you can just pull up the table doing that. That kind of speeds up the process. Yeah, so this, if I did 8 minus 2, that's 6. 6 times 180 is 1080. All right, and then let's see here. So that's just how I'm going to fill out the rest of these values. So 9, you get 1260. 10, you get 1440. 11, you get 1620. And with 12, we get 1800. Why? Because 12 minus 2 is 10, and 10 times 180, just add another 0 to 180, 1800. See? And then for n, that's just, I guess, n degrees. I don't know. I don't really know what to put there, to be honest with you. I don't remember. When I made this, I don't remember why I put it in there. But, okay. Find the sum of the measures of the interior angles of a convex octagon. Okay, octagon has 8 sides, so the answer's in that table right there. But just to show my work, 8 minus 2 times 180, that equals 1080. All right. Looking at this next example, we can count that it has 5 sides. Okay, so if it has 5 sides, looking at the table, or 5 minus 2 is 3, 3 times 180 is 540. So, because it has 5 sides, I'm going to add all these interior angles up and equal it to 540. So, I'll just do it right here so I don't have to go back and forth. I'm gonna, let's see here. How many sides do I have that are 2x? I have 2x sides, plus I have 2 sides that are 3x plus 14. And then I have 1 side that's 142 degrees. And that's all should equal 540 degrees. All right. Now let's distribute these 2's. So I get 4x plus 6x plus 28 plus 142 equals 540. And let's add our like terms here. These 2 are like terms and these 2 are like terms. So 10x plus this is 170 equals 540. Okay, now I'm just solving for x. Minus 170, minus 170. 10x equals 370. Divide by 10, divide by 10. X equals 37. Okay, so then I just plug in 37 back into this. So 2 times 37 is 74. 2 times 37 is 74. 3 times 37 plus 14 is 125. So I get 125 here, I get 125 there. And a good way to check your work is to just add all those back up. And so this is my check step. I'm going to add 142 plus 74 plus 74 plus 125 plus 125. And by doing that, I see, type it into my calculator, and I see that it does all equal 540 degrees. Yay. All right. Now, we're going to go backwards. So it says, given the interior angle measure of a regular polygon, you can also use the polygon interior angle sum theorem to find a polygon sum of sides. What that means is, remember, a regular polygon has all congruent angles. So if I say find the measure, or if I say the measure of an interior angle of a regular polygon is 135, that's 135 degrees for each angle on the inside of that polygon. So if you just multiply 135 times the number of sides, you'll get back to that polygon. And this is what I mean. Looking at like this, The reason why we got 1260 here was because we did 9 minus 2, that's 7. 7 times 180 is 1260, okay? But if I did 1260 divided by 9, if it's a regular polygon, I can do that. 1260 divided by 9 is 140. So that tells me each angle inside of this is 140 degrees, assuming it's regular. See how this example was an irregular one, but it still added up to 540? But if it was regular, all those numbers would have been the same. So basically what I'm going to do is I'm going to multiply 135 degrees times n number of sides, and then I'm going to set it equal to that formula we were looking at earlier, the n minus 2 times 180. Alright, and so visually this makes more sense if you just distribute that 180. You know, maybe it looks a little nicer if I wrote it this way, 180 times n minus 2. It's the same thing. I'm going to distribute. I'm going to write 180n minus 2 times 180 is 360 equals 135n. And so now I just need to get n by itself. So I should minus that 180n to the other side. And 135 minus 180 is negative 45. So negative 45n equals negative 360, and so negative 360 divided by negative 45 is going to get me 8. That's the number of sides. Alright, so n equals 8. And so you can always check your work by plugging in 8 into that formula. 8 minus 2 is 6. 6 times 180 is, so while I'm talking, I'm typing in 6 times 180. I get 1080. I could have just looked at that table. Now, okay, but it said 135. So what's 1080 divided by 8? So 1080 divided by 8 gets me 135. See? So I kind of went forwards and then I went backwards to check my work. So you may or may not want to do that every time, but I just thought I'd tell you because I'm a math teacher. So the measure of an interior angle of a regular polygon is 144. So I'm going to write 144n. I'm going to multiply that by the n number of sides equals 180 times n minus 2. Or you could just skip ahead and say 180n minus 360 because it'll set up the same way every time. And so I'm going to minus 180n again. And 144 minus 180 is negative 36n equals negative 360. So that means when I divide, I get 10. N equals 10. So that's 10 sides. Alright. And then here's the polygon exterior angle sum. The sum of the exterior angles of measured angle the sum of the exterior angle measures of a convex polygon, one angle at each vertex, is 360 degrees. I like to remember this by saying, you know, if you went full circle, you went 360 degrees. So if I drew a circle around this, then I know it's supposed to equal 360 degrees. So I may or may not help you, but it just helps me remember that. So if I put a circle around it, it's going to equal 360 degrees. But yeah, so all I'm going to do here to solve this is just add everything up and equal it to 360, and then I will have figured out x. So let's see, I've got 2x minus 5 plus 3x plus 10 plus 6x minus 5 plus 5x plus 2x. And I want this all to equal 360. Okay, so when I add up all my x's, I get 18x. when I add up -5 plus 10 plus -5, that equals 0. So I have 18x plus 0 equals 360, which just means I can divide by 18, and I'll figure it out x. So 360 divided by 18 is 20. So x equals 20. And there we have it. I could just plug in 20 into each one of these, and I could figure out the angles. So 2 times 20 is 40. 40 minus 5 is 35. 5 times 20 is 100. 2 times 20 is 40. 6 times 20 is 120. Minus 5 is 115. 3 times 20 is 60. Plus 10 is 70. And then you can always check by going, what's 35 plus 70 plus 115 plus 100 plus 40. Type that all into your calculator, and you get right back to 360 degrees, so you know you did it right. And that's it for 6.1. Hope this helped. Goodbye.